Hi, I'm Itzik. I'm going to explain shortly about the main idea behind our paper, multi-qubit gate with trapped ions for microwave and laser-based implementation. In our proposal, we show how to realize the monomer source gate or the geometric phase gate with trapped ions while still being decoupled from the main sources of noise using continuous dynamical decoupling, as I will now explain. In the microwave-based implementation, we consider the use of a large static magnetic field gradient, which enforces our qubit to have a magnetic sensitive transition, which causes the qubit to be sensitive to the magnetic noise. To fight that, we can use continuous dynamical decoupling, so we apply on-resonant driving field with this transition, which takes us to the dressed basis, which is protected against the magnetic noise. By doing so, the magnetic gradient becomes the red sideband transition in the dressed basis, which yields effectively in the second perturbation approach the flip-flop Hamiltonian, in addition to a phonon dephasing term. The magnetic noise is not the only noise in our problem. The second important noise is the noise comes from the Rabi frequency fluctuations of the dressing field. To fight this one, we can use the same technique as before. We can apply second dressing field, which takes us to the double dressed basis, which is now protected against the Rabi frequency noise of the first dressing field. So we are left with the Rabi frequency noise of the second dressing field, but this one is assumed to be much smaller. Now, the red sideband Hamiltonian becomes our gate Hamiltonian, and this effectively gives us the geometric gate Hamiltonian or the source and monomer Hamiltonian. We simulate this for different cases and we see that we can reach very high fidelity. More in this paper, we calculate the neglected terms and their contribution to the fidelity. We show how robust our model is to the main sources of noise. We explain how to move to the interaction pictures experimentally, and eventually we also show that we can realize the same scheme but for the laser-based implementation. Thank you for your attention. I hope that you will enjoy reading the paper. Bye.